cells, just like we did initially. So you'll see that we have angles from 0 to 20. Now we want to make sure that our velocity is carried all the way down. If you refer to your velocity on the last page, you're going to have to put in an equal sign and then select on the velocity on this page. And you'll see that it's actually equal to the velocity that we referred to on the other page. And when I say other page, I'm talking about 0 degrees. So I want to fill and drag this on down. So that means we're going to have the initial velocity for every angle that's fired. Now, I will agree that it's possible that the initial velocity is changing for every angle, but this is another assumption that we're making. And I've done this before, and the change is not that great. But it does change a wee bit. So let's go ahead and look at our angle in radians. And you'll notice that our angle in radians is just referring back to column B. So it's a calculation. So all we have to do is track this down. And please don't drag over your previous value. It's a kind of a check for us. And A, it's actually column D, but it's A from the quadratic equation, is just a calculation. So it's not referring to anything. We can just pull that down. And then we have B here, which is a calculation. And it's referring back to column A. And it's also referring to column C. So we can just drag this down as well. This is actually the initial velocity in the y direction. So notice that it increases, as it increases to an angle of 20, the velocity actually increases in the y direction as well. At 0 degrees, there's no velocity in the y direction, which makes sense. And it just incrementally increases, okay? Now, I placed this increments in here. I'm just gonna delete that because I did that before and I had made a mistake and all of that stuff. So this is how your sheet should probably look. Let me just not fill this. This is the way your sheet should probably look. And I'm just gonna go ahead and select on this value. This value was measured. It's coming from the following two places. So we have our average displacement right here. So we negate that one. And then we have our average displacement from 20 degrees. And so we negate this one. So this is where these two values are coming from. We don't want to mess with those. So I'm just going to put something like, I want to put some kind of red, but let's put some kind of orange here. And it's just really to indicate, don't mess with me. That's all I'm saying. Don't mess with me. So let's insert to the left, and we're going to increment. So we're going to create an increments column, and we want this in meters. So this is equal to, now what we want to do is we want to take the difference between the height at 20 degrees and the height at 0 degrees and then divide it by 20 to develop these increments. So I'm going to go ahead and take this one. Actually, I need some parentheses. So I'm going to take this, subtract it. Subtract what's happening at 0 degrees. And then we want to divide this by 20. If you need to pause the video right now and write this in, fine. And now I just want to, if I pull this down, watch what happens. I'm just going to fill this down. Look, I just have zeros. It's not what we want. So if this error is occurring, let's just go back. What we want to do is we want to say equals to and then select on increments. And now it's not 0. If I fill, it's just going to go all the way up. So I can just fill all the way down here. In fact, I'll probably fill even further than that at some point for extrapolation. But in this particular case, we have this. So let me go ahead and build this formula. Say equals to the previous position plus our assumed position at 1 degrees. And now that we have that, we should be able to pull this all the way down.